Hello everybody and welcome back. So in this next lesson we're going to be talking about loops. So because we've covered arrays now, we want a way to work with these arrays and all the data that we've stored within them. So generally the best way to do this is to loop through it. In other words, we're creating a block of code and then we go one item at a time through that list or through the dictionary and apply that block of code to each of those items. And in each case, we need a variable to basically store that item that we're busy processing in that variable, and then within our block of code, whenever we reference that variable, what we're actually referencing is that one item. Then as we go into the next loop, the variable changes to the next item in the list. That's the general idea of what a loop is doing. So I'm going to put together an example here for you to just kind of show you the very basics of what a loop is doing, and then we're going to talk about the different types of loops and how to loop through different arrays as well. Okay, so let's create an array for ourselves. In fact, let's code in this Python source editor, and we'll just be printing to this terminal over here. All right, so I'm just going to import who, and let's create an array. So we're just going to start with a simple list. I'm just going to put a few numbers in here. Also, I'll have a float and then maybe a few strings as well. Okay, so just a couple of items. And right, so let's create a very, very simple loop. Basically the most simple thing we can do. Now, you've got two different types of loops in Python. There's a for loop and then a while loop. So a for loop is going to loop through an entire array. So essentially the number of times that it iterates is going to be based on the length of the array. Whereas a while loop has a condition that it checks. It's almost like an if statement where it's checking a certain condition, but what it does is it says, is this condition true? If so, then repeat the loop and keep looping until that condition is false, right? So we're going to start with a for loop, which is the most basic one. Now, when we type for, you'll see it's one of those reserved keywords, so it goes purple, so we know we're doing something right. Now, essentially the syntax here is we're saying for something, so for y in x, right? This is the format. Now, what this means is here, this at the end is our actual list, okay, our array, okay? Maybe I should give it a longer name, because sometimes these small variables can be a bit confusing, because normally when you're doing a loop you'll use like just a single letter here. I mean, you don't have to, you can use any variable name you want, but normally we want to just sort of use a single letter here. But then something more significant like an actual list, will give it a bigger, longer, more descriptive variable name. Okay, so we're looping through my list, and you can see that where it says in my list. So that's quite obvious that this is the list that we're looping through. But the for and then this variable name, it basically means that as we loop through this list, the very first time we loop, y will be equal to the first item. Okay, so as we enter, y will be equal to 4. It's going to do everything in this block that we type, assuming that y is 4, and then it's going to leave that and loop right back into the start, but it's going to say y equals 7, and then it's going to repeat the block, but with now y being equal to 7. So a very, very basic thing that we can do is just say print y. Okay, very, very basic. But this is going to show us what is happening, because we're setting y to be equal to 4, then we print it. So it should print 4. And then the next time it loops, y is equal to 7, and it's going to print y, so it's going to print 7. Okay. So basically we should print each of these items one at a time in our list. Okay. And if I hit apply, you'll see that's exactly what happens. prints 4, then 7, then 3, and so on. Right? So you can now see that why this variable changes. Okay. Now, please be careful with these variables. Do not, you can't use variables that already exist because it will grab any other variables that are set outside of here. So for example, if I had to say that, y equals to something out over here, then you probably, you're going to, yes, when it goes into here, it's overriding it, but then over here, then you're going to find that y has been overwritten with something, because in the loop it says y equals something. So now after this loop, when we print y, it's printing something instead of 5 because we've overwritten it. Okay, so you must be careful. This is an actual variable that gets set. Okay, so this is very simple, and inside these loops we can now do whatever we want. So we can do much more complicated things than just printing it. We could convert it to a string, or we could, so maybe let's do something a little more complicated. Let's take my new list, and we'll just create an empty list. Okay, because what we're going to do is we're going to loop through this first list, and for every item we're going to add it into this new list, but we're going to add it as a string. Okay, and maybe let's prepend it with something, or I don't know, let's do something cool. So let's go my new list dot append. Okay, and what we're going to append is the new value. So I'm going to use a variable. Just you could do this calculation, whatever I'm going to type here I could just put directly in here, but it's much easier and more visually simple to set a variable and then just feed that variable into the append. So if I just had to say y over here, then it's basically saying y equals to 4, so val equals y, which means val equals 4, then 4 just gets appended to this list. So very, very basically, it's just going to reassemble the same list. So if I just print my new list, okay, it's going to be exactly the same because it's done that. That's kind of boring. Well, what we can do here is maybe convert this to a string. Okay, so now it's created a whole new list where it's an actual string of 4 and 7 or whatever. And I mean, we could maybe even do converting to a float in here first. Okay, but then that's going to error when it hits these the text over here. But let's say we didn't have that, then we'd be able to get that out of it. You see, so it's going to convert them to a float, then to a string. So they will be strings, but they will have 0.0 in them. Okay, so there's all sorts of weird things that we can do inside of here, but basically the point I'm trying to illustrate is we can write this whole block of code where we reference y as our variable, and that is going to apply one at a time to every item in this list. Okay, now what happens if we need to loop through a dictionary though? Because a dictionary is a lot more complicated. So let's say my dictionary, and then let's build some items in this dictionary. Now I have typed a very simple dictionary before just in one line, but I actually want to show you that it's a lot simpler to go and type kind of a dictionary spread over multiple lines like this. It's actually exactly the same. All the characters are exactly the same in order, but to read it is so much simpler. So let's just do, let's use our car example again from the previous lesson. So I'll say color, let's just go, let's just make it a red one again. So a red car, and then we put, a comma there, and then we'll put year 2019, don't forget the comma, and then let's put wheels 4. Okay, so you'll see in here typing it this way makes it a lot easier to kind of read. In fact, we can even put spaces in here, so we can kind of very easily see the layout of this, right? So we can't just loop through a dictionary in this exact same way, okay? Because we have these two different, it's a dictionary is sort of almost two lists, but it's just that the one list has an association with the other list, okay? So we have a list of keys and a list of values, but technically the key knows which value it's attached to, right? So remember we had that, so if I print my dict, right? So like that, if we printed dot items, it gives us a list of tuples which are a pair of the key value. Okay, so key value pairs as a tuple inside of a list, right? And then we also had dot keys, which gives us just a list of the keys, and values, which gives us just a list of the values. So these are what we can loop through. The for loop, you cannot just feed it a dictionary, but you can feed it a list. And so we're going to use these functions to convert our dictionary to a list that is iterable. Okay, so if I just say for my, let's just say for x in my dict, I just want to show you that this is not going to work. Okay. Oh, okay. Well, it does work, but it really only looks at the keys. It's similar to some of these other functions. When you feed it a dictionary, sometimes it will break, and depending on what the function is. And in this case, I actually didn't expect this to work, but really, what it's doing is just looping through your keys. Okay, not what we want. I mean, even if we wanted to do that, I would rather feed it an actual iterable list, because you can do other things to this list as well. So it's much better practice, even if you're going to loop through just the keys. So we would say k, often k is used for keys. So as I said before, you can use any variable you want, but remember, you need to read this later, or someone else might need to read your code. So we generally try to stick to certain conventions or practices, like k for key, v for value, and also often we'll use I for like an index. Okay. So some sort of counter or like iterations. Okay, so I would never do this type for k in my dict and then just print k. Okay, that is not that good. What you want to do is actually run this function, and I know it's going to print exactly the same, but the thing is, this is much more understandable. This is quite clear that I'm looping through my keys, as opposed to you having to understand that actually if you don't run the dot items or dot values, then technically what I'm printing is keys. Okay, because it may be simple when there's a few lines of code like this, but don't forget, we're going to be working with really massive scripts, and those can be confusing as it is. So rather, let's be explicit. All right, so this is a way of looping through my keys. I can also loop through my values. So let's change the variable. As I said before, we don't have to. Technically, it could be k and it'll still do values. This is what matters. But I like to stick to these conventions so that it is quite understandable. Okay, and there's our three values. So it has gone one at a time through those values, like with this list, and just printed that. But if we say dot items, okay, and I print now, what it's going to print is that entire tuple as a key value pair, right? Now this is fine. We can do this. We can work with that. So we could use x, and then what we could do is say we could print x and then just 0. So the key is x, and then remember, because we're grabbing the first index of this list, you can put 0. So you could print x0 and we could print x1, okay? And then it's going to print, for each one, it's going to print key value, key value, key value, okay? You can do this, but there's a much, much better way, and a way that you're going to see much more often. So rather use the way that is expected, which instead of having to, like basically because items is returning a tuple, in this for, instead of feeding it one variable, if you give it as many variables as there are items in the tuple, then it will assign each item in the tuple to that variable, the corresponding variable in the list. Okay, so let me show you what I mean. So if we say 4k comma v in mydict.items, now we're giving it, this is returning a tuple that is a length of 2, so 2 items, a key and a value, and then we give it 2 variables. Instead of storing each one as now a tuple, it stores the first item in that tuple under k, and then the second item will be stored as v, right? So now if I go and print k, you see that that's just printing my keys, but I have v in here as well, and I can print v, and there's my values, right? So I could print k and print v, right? And that's going to give me the exact same result as before. It's going to print key value, key value, key value, right? So this is the way we normally loop through a dictionary. And now within this block, we can do whatever we want, but just, with k and v as keys and value, right? So we could do something like, for example, we could even entirely reverse this dictionary, as in set all the values as keys and the keys as values. So my dict2 equals, and I'm just going to give it an empty, so I'm going to create an empty dictionary. So you can do it this way, or you can do it that way, either way. Okay. And then as we loop through this, we would then say my dict2. Now remember, with a dictionary, when we want to set a value or even add a value to it, we can just give it in square brackets. We can refer to the key, right? So the key that we want to refer to, and then we say an equal sign, and then we put the value that we're wanting to store, right? So this is the way that we would store a new key. So what we want to do in this case is store v, which is that, as the key, and then the value would be k over here. So we're trying to sort of reverse this dictionary, okay? And now when I say print my dict2, okay, we then have this dictionary, but it's backwards. Okay, we have the color and then the word color, the year, and then the actual word year, the number 4, and then the word wheels. Okay. Not sure why we would want to do this, but maybe there are some kind of cases where you've been given a dictionary that is already backwards for some reason, and you want to work with it the other way around. You can just reverse it this way. Okay. So, yeah. Lots of things we can do, and we will be using this plenty later on, so good to memorize this now. Okay, so something I want to talk about now, which is often going to help, especially when we're wanting to loop, but when we're wanting to loop a number of times. So sometimes we have a list like this. We have a list that we want to loop over, where we know, okay, the first time I want my value, my variable to be 4, then I want it to be 7, then I want it to be 3. We actually have a list to loop over. But sometimes we don't. We just want to do something like 10 times. Okay, so we want to repeat a block just 10 times. So instead of having to go and create a list and fill it with 10 empty values just to be able to feed it to a for loop and say loop 10 times, but we're not even going to use the value in that list. There's a much easier way, and that is using the range function. Okay. So what range does is it generates a list, but from a sort of within a range of numbers. Okay. So there's a number of arguments that we can feed this function. If we give it just one number, okay, then this is where it will stop. So you see there's 2 different versions of this. You can either give it range stop, so just one argument, and then it's going to give a list of integers up till that number. Or you can give it start and stop with step as an optional argument. Okay, so let's start with the most simple one. If we type range 10 and print that, it literally prints the numbers 0 to 9, okay? Because it starts from 0 and it prints 10 numbers, so 0 to 9. if we then go and rather set a starting point, so we say 5, 10, so that's using the other alternate version of range, which has two, a start and a stop. Okay, then we're going to start from 5 and then stop before 10. Okay, so 5 to 9. Okay, in fact, let's increase this just so we get a few more numbers. But yeah, so we say where we want to start and we say where we want to stop. And then optionally, we can feed it an increment. So if we say 3, what that's going to do is it's going to print the first number, then it's going to add 3 and add 3, but we'll stop before the number 20. Okay, so here it only reaches 17 before it stops, because it can't, if it adds 3, it's at 20 and the cut is just before 20. Right, so you could even add like really large increments here, and so you'll get far fewer numbers, and you'll need to increase this, and then we can get a whole range of numbers that are 6 numbers apart. Okay, so this is a very useful function for a number of reasons, but one of the most common uses for it is to just say, well, I want to loop 10 times. So then you would just say for x in range 10. And that says do whatever is in this block 10 times. Okay, so then I could do something like, I don't know, let's create a string. So let's, on the outside, let's go myval equals, and then let's just print, I don't know, let's just type foo. I honestly think the worst thing is coming up with these examples, because you think like, hang on, I'm trying to think of some time where I've used this, and you use it every day, but then when it comes to actually thinking about like, how did I use this last time? It's really hard. Anyway, so we just got a myval over here. Now what we're going to do is we're going to take myval and add myval to it. Okay, so add it to itself, right? But we're doing that 10 times, and then when we print myval, what you'll see is, and this will be exponential because obviously we're using the same variable, so once we've set it, then when we go in, we add it to itself, it's gotten like super huge, so now there's tons of it. Let's say if we go and do it twice instead, you'll see that it goes and takes, essentially goes foo, then it adds foo to foo, so it does 2 of them, and then the last time, the second time it iterates, it adds foo to the end of that. So it doubles every time, okay? So that we've got there 4 of them, but if we take it just to 3, just one number up, we end up with double that. And then 4 will be double that, and so on, okay? So very weird example, but whatever it is that you want to do, you just want to do it 10 times, like we can create nodes in Houdini. Well, if you want to create 10 nodes, so you generate the code to create one node, and then you put it inside of a 4x in range 10, and then it will go and create 10 of those nodes. And what's cool is because you can feed in a variable over here, it means that you could even ask the user, tell us like how many nodes do you want? And then the user can input 5, and then it will take their input, feed it into this range, and then loop to 5 times. And so then now they're in control of how many times this thing loops. Whereas if you had to actually write the code out 5 times to create 5 separate nodes, now what if the user wants 6 nodes? And you have to actually change the code. So looping is very, very useful. Okay. So let's talk about while loops. Because these are, we've done 4 loops now, so we need an actual list to iterate over. Even if we're just wanting to loop so many times, we're using the range function to just create a temporary list. But a while loop is very different. A while loop says, very much like an if statement, you're going to give me a statement, a Boolean function, that says, true or false. If the value that is fed into it is true, then it will do the block. It will perform the block and will exit the block at the end. So we'll loop back. Okay, so we say while, and then so we need to give it some kind of value. So here we already have a y. Okay, so let's use that. Let's say while y is less than 20. Okay, now is y less than 20? Yes. Like right now y is 5, so 5 is less than 20. So this is true, which means that whatever's in this block is going to actually happen. But then when it reaches the end of the block, it's going to loop back in, and it's going to check again and say, is y less than 20? If it's true, it's going to do it again. Now please be very, very careful. You can create infinite loops here. Okay, if I just did something innocuous in here, like I just go print y. Now, if I executed now, I'd end up with an infinite loop, because 5 is always going to be less than 20. So it's always just going to print 5, print 5, print 5, print, and it's just going to never stop. So when you do while loops, you're very much at risk of having an infinite number of loops. So please be very careful, okay? So in this case, we would only do something like this if we're planning on incrementing y inside of the block. So you'd say y plus equals 1, which means that every time it loops, it adds 1 to y, and then it prints it. And then it goes back in, adds 1 to it, and prints it, which means that eventually y will not be less than 20, and then it will stop. Okay, so then we can just go here, and when we print, you'll see it prints 6, 7, 8, all the way up to 20. Okay, so that's very, very useful, very, very powerful, but also sometimes a little scary, so you need to be careful. In fact, I'll show you something that I do, because this is going to actually segue into something else I want to talk about, is breaking out of a loop. But what I often do, even if I know that I have a condition like this set up where I'm going to be incrementing, I will put in my own sort of loop counter and set a very high number, but then kind of say beyond this number, just kill this function. Now, I won't do that if we're talking about something that's going to loop through points or whatever, because you never know. The user could put in a million billion points, and if their machine can handle it and they're willing to wait for it to process, then fine. So I'll never do this with something like that where the variable is so wide. But let's say I know it's something that should be, less than 20. Well, then I'll set my maximum range to like in the thousands or even millions, and that's fine. It's just that it prevents it from being infinite. Okay, so what I'll do is something like I'll just have maybe a counter or something. So I'll just say count equals 0, and then so you initialize it on the outside. So because remember here we're saying count equals 0, but then this line of code happens. So then this, when we add to count, the count will increase every time. It doesn't keep setting it to 0. If we put this inside of the block, then every time it loops, count would be reset back to 0. Okay, but instead we set it on the outside, and the very first thing I do as I enter the code is say count plus equals 1, and then immediately check to say if count greater than, and then I'll choose a number. So in this case, we were really talking about low numbers. I might set something like 1,000, but you can even go and add a couple of zeros to that, just to be really certain that this will never, go infinite, in case you're worried about that breaking. So I'll just say 1,000 for now. So if count goes above 1,000, then, and now here, this is the perfect segue into talking about how to break out of loops, because sometimes you need to actually exit a loop prematurely for whatever reason. Okay, so sometimes you actually deliberately design these loops to be fragile so that you can break out of them based on certain conditions. So you sort of set up intending to loop 1,000 times, but you're actually searching for a certain condition, and so you start looping, and as soon as you hit that condition, you exit the loop. So what you're doing is you're attempting, it's kind of like trying to, get a basketball through a hoop. Okay, if you say I'm gonna try this 1,000 times, well, if you get it in on your first go, you don't need to keep trying. You did it. You did what you wanted to do. So you don't have to do it all 1,000 times so that at the end you say, okay, well, I did it. You just do it once, and if it goes in, then it does. And if it doesn't, then you try again and again and again. And only if you reach 1,000 and you still haven't got it in, then you give up and maybe try a different sport. Right, so here we say, so there's two, well, there's three, but I'm going to talk mostly about two. So there's continue and break. So let's use break, okay? So, because in this case, I would use break. So break says exit the loop immediately. So it won't process anything after it. And it will not, no matter what, it will not re-enter the loop. So break essentially says go from here to here, the next line of code outside the loop, and then just continue, like carry on from this point, right? So skip that, and it doesn't care whether y is less than 20 or not. It just says, nope, I'm done. I'm just out, okay? So break, that's why you would use it for your loop counter here. So now you can kind of set yourself up. When I print here, you see it's stopping. But let's say, just for interest's sake, I'm going to set this loop counter to 100, okay? Just as a, fail safe, so it's a little bit less, okay? And then I'll go and let's say we forgot this line, okay? So we forget this, or somehow we comment this out, okay? Because sometimes that does happen. You're editing code, so you go and comment something out, which means that this line doesn't apply, okay? That's why it's gone yellow. Now, I've accidentally commented this out, and I go and click apply. Well, instead of hitting an infinite loop now, it's just gone and printed 5 100 times. Okay, so it's done it 100 times, but then it's actually stopped, because after 100 it hits this break function and says, okay, I'm out, and it just skips over to here. Okay, so that's a very good way of using break, but sometimes you'll want to do it for any other reason as well. You might want to say, for example, okay, let's edit this out. We can also do it with for loops, so I'll go back to a for loop. I'll say for x in my list. So we're looping through our list, and we will say we want to print x, but if maybe the length of the string of x. So in other words, if we take our x, convert it to a string, then check the length of it. So in other words, how many characters form this? If that is greater than, should we say 5, then break. Okay. Now, when I print this, let's give some lines over here so we can see. It prints 473, 6.34, and foo, and then when it hits something, the word something, this statement, it takes the string, which is already a string, so it just leaves it as is, takes the length of it, which is, how many is that? 9, okay? So 9 is greater than 5, so then it breaks, and it does not print. So you'll see it skips this function, so it doesn't print the word something, and it breaks out of the loop. Now, if I had to move this word something to earlier on in the list, okay, and now I try that. So if I hit apply, you see it prints 4, it prints 7, then it hits this, the statement says break, and it exits the loop, and that's it. We're out of the loop. Instead of doing that, if what we wanted to do was skip the rest of the block, but still re-enter the next loop, okay? So in other words, just don't continue, like don't finish the rest of the block, but still continue looping, then we use the word continue instead, right? So continue does not say just skip everything and go to here. It says skip the rest of the block and go back to here. Okay, so now we'll get a bit of a different result. Exact same condition, but if I say apply, it prints 4, it printed 7, it skipped something, so it hit this continue and said, right, well, I'm not going to do anything in the rest of this block, went back into the loop, went to the number 3 and printed it, printed 6.34 and printed foo, because all of them did not meet this condition. Okay, so it's only the word something that it skipped, and then it continues doing the rest of them. Okay, so that's why it's called continue, because it literally continues the list, whereas break actually breaks out of the loop entirely. So the loop is broken, nothing will continue. Right. So that's our continue and break. Now, something else that you can do with both for loops and while loops is you can use the else statement. Now, I know this is a little counterintuitive because it doesn't really seem to make sense. You say for this and then else that, but what else really means in this case is after all of this, do this. Okay, so it's kind of like saying at the end, once you're done looping, then do this, right? But sometimes if you don't do any loops, then the else statement won't occur, because if you just have nothing over here and you just have a statement afterwards like print done, then of course it's going to loop and then print done. But if it never does any looping at all, if the list is empty, it's still going to print the words done. Okay, so we do this, hit that, it prints 4, 7, and then done, because that's over here. If we put an else statement and tab this in and do that, okay, then it will not print this because it broke out of the loop here, right? Now let's say we disable this break and now do it, then it prints done. Okay, so what we're essentially saying is in this else statement, it is going to do only what, well, it's only going to print everything or do everything in this block if it has successfully completed this loop, right? Because the break is going to tell it to jump all the way to the outside of the loop, which will skip the else statement, right? Now let's change this to continue, right? Give it some lines and then say that. Now see, with continue it will print your else statement, because continue is saying, okay, just skip that one, but it doesn't tell it to jump to here, it jumps to the beginning, and so it keeps looping and then it does your else statement, right? Now what if we also say go over my new list, which is empty? Okay, then it will still hit this else statement even though the list is empty. Okay, let's do it with the while as well. So we go back to our while loop. So the while, let's just double check that it still works. We're going to print the numbers 6 to 20. Okay, and then we're going to break. Now here we have our else statement, so let's print done, give it a few lines and say that. So it's going to print 6 to 20 and then print done, and it will not print after that because obviously it has broken out of that statement. Okay, so I find that I don't use this often. Most of the time, just, you do a loop and then that's it. But there are rare occasions where you would specifically want to say, okay, well, if I successfully completed this list, then do something. But if I break out of it, maybe we set up an error where if we come across a certain error, we're actually going to break out of the loop and then do other things. When breaking the loop, it will then skip the else statement. So then we can have only things that are specifically meant to be based on the results of the loop would go inside the else statement. So that if we don't successfully complete the loop, of course we don't want to complete this block that relies on the results of the loop. Okay. And then there is one final thing that I want to talk about when it comes to looping. So I'm actually going to go back to the for loop just because it's a little bit easier to demonstrate on this. Okay, so what I want to talk about is nested loops. Okay, so let's say, right, why don't we do this? Okay, I'm gonna create just a list of strings. Okay, because strings themselves are actually arrays as well, right? They're basically a list, like an ordered list, where you have S is the first index, O is the second index, M is the third, and so on. They're literally just characters stored in an ordered list. Okay, so you can treat strings very much the same way that you can treat any other array. So we have a few words here. Okay, so as I loop through my list, when I do the first loop, X is equal to something. But what if I now, inside of here, want to loop through the actual word, so one letter at a time? Well, because X is now equal to something, I can have another loop inside of here. I can say for X in X. Okay. Now, so X is our list, right? So our word. But you need to be very careful, I did this deliberately, to not use the same variable that is here, okay? Even if we weren't specifically looping through that list over here, whatever we were doing, sometimes inside of a list you might have like, you know, actual nested lists or whatever. So you would then loop through something else inside of here. You still want to say, use a different variable. And the reason for this is because you need to be very careful. This variable X is stored, right? So X has a value, which is something. If we use the same value over here, it's going to override it. And then for the rest of our block outside of this one, X will be equal to literally the letter S instead of just the whole word something. Okay, so you need to be very careful. You can do this like where you inside you use the 2, so it'll be x2, y2, whatever. You can just append it like that, or you can use an entirely different thing, maybe for I in, or maybe let's use L, because what we're saying is generally what I do is I think of like what it is that I'm looping. So I want to say, well, I want to look at each letter at a time. So a letter starts with L, so I'll just create that as my variable. That's my own kind of thinking behind it. It just makes it kind of more intuitive. Some people do like to use literally full name variables, so you'll say for letter in X, okay, and then over here then we can say print letter, okay. Maybe we should still print X, so we're going to print X, then we're going to print each letter in X, okay. So we can just go back over here, and if I do this, right, so it prints foo and then FOO, and then it prints done. Now the reason for that is because obviously we're continuing here whenever we hit something greater than 5, right? Obviously if we disable that, or maybe just increase this, so like 20 or whatever. So we're basically saying, I'm not going to accept any strings that are greater than 20, just skip those, but any smaller words, sure, go ahead and do them, all right? So now it prints something, which is X, then it prints S, O, M, E, and so on. Okay, so the actual variable letter, the first time it loops is equal to S, and then it's equal to O, and so on. Okay, but because it's inside here, you do not want to override your other variables that you're busy using, including any global variables. So you don't want to store it as Y, because like I showed you before, if we override it, then Y has changed as well. Okay, and you can have other loops, so you can use a for loop, but then you can have a while loop inside of a for loop, or you could have a for, for I in range 10 print X or something like that. So then we would disable this part, so then each one of them, it prints it 10 times for some reason, and we really want to drive it home. So there we go, something and foo and then whatever, and we print that 10 times. Okay, as long as these variables are not overriding one another. Okay. Right, so that about does it for loops. They are extremely powerful and very commonplace, so you're going to use them all the time. So you will get to practice this as well a lot as we move forward with the practical examples. But I hope it made sense and clears up a lot for you. So thank you very much, and I'll see you all in the next lesson.